In this video, we're going to take a look at solving problems using half-angle identities. So the half-angle identities can be found by evaluating our power-reducing identities for theta over 2 instead of theta, and then taking the square root of both sides. So here we have our power reduction identity for cosine squared, and if we evaluate this instead of theta, if we evaluate it for theta over 2, what we get on the right-hand side is 1 plus the cosine of, 2 times theta over 2 is just theta. So cosine squared of theta over 2 is 1 plus cosine of theta all over 2. And then we can just take the square root of both sides, noting that we have the positive or negative based on, it's going to be based on where theta over 2 ends up. So if it ends up in the, let's say, third quadrant, if theta over 2 ends up in the third quadrant, that's where cosine's negative, so we'd use the negative. If it ends up in the fourth quadrant, theta over 2 in the fourth quadrant, then we would use the positive because cosine's positive in the fourth quadrant. So cosine theta over 2, sine theta over 2, and tangent theta over 2, here we have for our identities. So make sure you have this written down. So example 6, find the exact value of the cosine of 112.5 degrees. Well, first of all, the 112.5 degrees is in our second quadrant where cosine is negative, so our final answer for this should be negative. Now, we could type in cosine of 112.5 degrees in our calculator. It'll give us a negative decimal approximation, but we want the exact value. The good news is we can test to see if our answer is right by putting our answer into our calculator and see if it gives us that exact same negative decimal approximation. So 112.5 is half of 225. So the angle that we're going to plug in for the right-hand side for theta is 225. So we know it's negative because in the 112.5 is in our second quadrant where cosine is negative. The square root of 1 plus the cosine of 225 degrees all over 2. Well, the cosine of 225 degrees is negative square root of 2 over 2. And if we clear out our tiny fractions here by multiplying both numerator and denominator by 2, we end up with negative the square root of 2 minus the square root of 2 over 4. Now, we can break this up as a giant square root of a fraction as the square root of the numerator over the square root of the denominator. So we get negative square root of 2 minus the square root of 2 over the square root of 4, which square root of 4 is 2. So the cosine of 112.5 degrees is an exact answer, is negative square root of 2 minus the square root of 2 all over 2. And if we type this into our calculator, it should give us the same decimal approximation again as the cosine of 112.5 degrees. Example 7, suppose theta is between negative pi and 0. So in other words, in the third or fourth quadrant. And the cosine is negative. Cosine of theta is negative 3/5. So cosine's negative in the third quadrant, which means theta has to be in the third quadrant where cosine is negative. So at least we know what quadrant theta has to lie in. We're going to find the sine of theta over 2. Well, the sine of theta over 2 is plus or minus the square root of 1 minus the cosine of theta over 2. And fortunately, we're told that the cosine of theta is negative 3/5, so we can plug that in. And multiplying our fraction by 5 to get rid of the tiny fraction, we get 5 plus 3. We have negative is plus 3 over 10, which is plus or minus the square root of 4/5. And plus or minus the square root of 4/5, if we break that up and rationalize it, we get plus or minus 2 times the square root of 5 all over 5. Okay. Now, to determine which one we should use, the positive or negative, if, again, negative theta or negative pi less than or equal to theta less than or equal to 0, if we divide each of these by 2, we get negative pi over 2 less than or equal to theta over 2 less than or equal to 0, which that's going to put theta over 2 in quadrant 4 where sine is negative. So this is between negative 90 and 0 for theta over 2. Negative 90 to 0 is in quadrant 4, and since theta over 2 is in quadrant 4, sine of that is going to be negative because sines are negative in quadrant 4. So as far as plus or minus 2 square root of 5 over 5, because we are in the fourth quadrant, sine is negative there, we're going to use negative 2 square root of 5 all over 5. All right, example 8, use the tangent of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 1 plus cosine of theta to derive the identity tangent of theta over 2 equals sine of theta over 1 plus cosine theta. So let's start with 1 minus cosine over 1 plus cosine inside of a square root. We're going to multiply the numerator and denominator by 1 plus cosine in this case. If we multiply by 1 minus cosine, we'd get the other alternate version of tangent of theta over 2. So multiplying this out, we get 1 minus cosine squared over the quantity 1 plus cosine all being squared. And 1 minus cosine squared is sine squared. So we have plus or minus the square root of sine squared over the quantity 1 plus cosine of theta all being squared. Which when we break this up as the square root of the numerator over the square root of the denominator, we get square root of sine squared is sine, and the square root of 1 plus cosine, all being squared, is 1 plus cosine. So tangent of theta over 2 is sine over 1 plus cosine. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.